Hello everyone, my name is Brittany Susie John and I will be presenting a technical review on the signature under seismic data processing subject. So this is the presentation outline. I'll be talking about the introduction of the signature, the development of this signature, problem statement and objective, followed by the technical review for 4 methods, and lastly the conclusion and recommendations. So, in recent years, regions with easily extracted hydrocarbons such as shallow sea and barren land are running out of economically feasible hydrocarbon. Thus, companies and explorers started to explore the deep water and more complex geological areas. And this condition has led the industry to improve and develop new technologies to overcome the obstacle. And since all hydrocarbon exploration stages, ranging from quantitative exploration to well drilling, and it emphasized on the importance of the seismic data processing, it is ideal to develop more robust algorithms to tackle all noises, especially ghost, directivity, and bubble effect in seismic data, especially for marine acquisition. So, what is ghost? Ghost is a signal waveform that occurs due to the reflection of the airgun pulses from the sea surface. And what happens if ghost present in the data? The TWT will be a bit late because the wave reflected to the surface of the water. So there are 3 types of ghosts, which are receiver ghosts, source ghosts, and both ghosts. For receiver ghosts, we can see the wave reflected to the sea surface before it arrives at the receiver. Next, for the source ghost, we can see the wave reflected to the sea surface before it goes to the sea floor and reaching the receiver. And the last one, both ghosts, this is the combination of the source ghost and receiver ghost. So, the ideal data that is favorable by geophysicists is the one that has no ghost scenario, directivity, and bubble energy, where only primary reflection is recorded and there is no reflections from the sea surface. Thus, process of collapsing the far-field signature into zero-phase wavelet is important to remove these signals using the signature and deghosting. Now, we enter to the designature evolution briefly. Here is the brief evolution of the designature taken from previous paper review, where we can see the evolution from the identification of the far-field wavelet has made the researchers to study and develop more advanced technology and methods over time. And each method has its own pros and cons in combating the ghost signal. From the reviewed papers, we've learned that the ghost produced by reflection at the surface will be superimposed on the primary reflection, and the conventional methods in removing the source signature is not suitable for all geological areas. Therefore, in this presentation, I will be sharing the different technologies and methods by various geophysicists to eliminate the ghosts with its effectiveness for each circumstances. So for technical review, I'll be sharing 4 methods with its results. So the first method is deterministic Airgun modeling. In this paper, they examine how physics-based modeling of the Airgun dynamics to estimate the source signature, where they use numerical model and they show that the simultaneous signature is comparable to that predicted by nucleus. So firstly, they model the Airgun dynamics, which underpredict the damping, observing the data with alpha damping constant to solve the underpredict damping. This is to solve the compressible Euler equations in the water. And next, they evaluate the solution of the bubble wall to obtain the modified Herring equation here. This is to remove the predictable information from the dataset and some of the ringing. But the disadvantage of this method is that it introduces artifacts in the seismic data. In conclusion, for this paper review, it is generally shows the deterministic modeling Airgun signature can be used to design the ocean bottom node data. So this is the result of method 1. A is the reflectivity model. B is the synthetic data generated by convolving the reflectivity model with a simulated signature. Same with C, but with lower psi Airgun. And figure D shows the prediction error filter that is applied to the synthetic data in B, where next, figure E is the synthetic data that is shown in B, deconvolved with the correct signature, and lastly F with the wrong signature. We can see here between E and F, where the figure E, it gives the clearer seismic than F because it convolved with the correct signature. So the second method is bandwidth optimized signature solution, or known as BOSS. In this paper or this technology, they use a hybrid signature that where the near field source signature are derived from PGS nucleus model software with the near field hydrophones. So the designature operator here is obtained by matching the raw far field signature to the desired phase wavelet. And the desired phase wavelet is designed to preserve the total energy of far field signature and preserve a full bandwidth as no predictable deconvolution is involved. And when we look at the result of hybrid technique between the BOSS and the signature, we can see that the ghosting has been applied at the right picture here, from here to here. And the advantage of this technique is that the PGS BOSS method ensures that the low frequencies of the signal have been zero-phased appropriately. So for the third method, which is directional designature using Bootstrap approach. This method uses shot-to-shot directional designature, where it addresses the potential issue of source designature instability and source directivity, where the near-field hydrophones measurements are used together with the Bootstrap approach. And in this paper, they show how the directional designature can more effectively remove the bubble effect and make the primary effect more coherent among the different azimuths. So this is the result for this method, where at this figure C, we can see that the directional designature attenuated the bubble energy much better than the 1D designature. So the last method is number 4, the spatially compact source designature filter. So in this paper, they propose the deconvolution operator that is designed to be an approximation of the inverse of the far field signature, source signature at small wave numbers, and only the characters of the sources needs to be known for its design. And the CSD filter is able to correct for shot-to-shot perturbations of the source's output and reduce the smearing. This method combines the CSD filter and CMS method to account the directivity of this method of the effects. This method is found to have a potential to account for some directivity and source ghost when applied to common receiver gathers. And in conclusion, this method has a small but visible improvements in terms of continuity, amplitude equalization, and resolution of the events. However, the range of validity of the approximation and noise level have made this method to have some limitations. So this is the result for this method, where we can see the both figure this here. This is for the shallow and this is for the deep window of brood stack. There is improvement in terms of continuity rather than A, B, and C. And when we compare the result between C and D, there is an equalization of amplitude throughout the section where the directivity effects are corrected when using the CSD filter. Now we have come to the conclusion and recommendation for this technical paper review. For the conclusion, we have learned that the designature process removes the source ghost, directivity, and bubble energy, which makes it as one of the most important processes to remove the noise from the data. And each method has its own advantages and disadvantages according to its application. And we've learned that the technology of designature in data processing is getting better as improvement keeps happening in industry. So for the recommendation for the future research in this topic, it is better to apply different methods in a single seismic data processing in order to increase the data quality. And it is also important for us to understand the geological setting to choose the better methods or combination of methods in processing data according to its suitability. This is the list of references taken from open source in order to do this technical review. With that, I would like to say thank you for your time in viewing this video.